Hello students, welcome to the Bridge course program of 9th standard maths in 6th day to 11th day program. That means we are going to discussing about the few fundamental concepts from Bridge course from 6th July to 11th July. Then there are few concepts which is related with the maths 1 as well as maths 2. First of all, I am going to discussing with you about the maths 2 concepts. Then see here, in previous lecture you have remind about the parallel lines and the transversal which made 8 angles, and there are different types of angle pairs are formed by transversal when it intersects to the two different lines at two distinct points, that are corresponding angles, interior angles, alternate angles and vertically opposite angles. Then first of all we have to remind those concepts. Then see here, we have to find out the corresponding angles, interior angle pairs, alternate angle pairs as well as vertically opposite angle pairs from the given figure. Then see here, suppose there are two different lines are there. Those lines, it may be parallel or it may be non-parallel lines are there, and when the transversal intersects to the two different lines, that is see here, the line L and M are given here, and the transversal T intersect to those lines into two different points. Then see here, suppose PQ is a line, RS lines, to which here the AT is a transversal which intersects to those two lines at two distinct points, that is M and N. Then we can write the names of corresponding angles. See here, first of all the corresponding angles, corresponding angle pairs. Then see here, the angle EMQ and the angle MNS, angle AMQ and angle MNS are the corresponding angle pair. There are few more corresponding angle pairs are there. You have to find out and write in your notebook. Similarly, see here, interior angles pairs, interior angle pairs. Then see here, the interior angle, here the angle NMQ or the angle QMN, angle QMN, and the angle MNS, angle MNS are the interior angle pairs. Then one more type, that is external alternate angle. External alternate angles. Then see here, the alternate angles are of two types, that is external angle, alternate angles. See here, the angle AMP and the angle PNS. See here, angle AMP and angle SNT are the external angle pair. And see here, the internal angle pairs, that are here angle PMN and angle SNM. That is fourth one, internal alternate angle pairs. Angle pairs are angle PMN and angle MENS are the internal alternate angle pairs, and there is vertically opposite angles. See here, angle AMQ and angle PMN are the vertically opposite angle pairs. Then you can write the remaining angle pairs to find out and finding from this figure. Then one more concept which is related with that is, there are theorems or properties which is related with those angle pairs. Then see here, if there are transversal intersects to the two parallel lines, see here, line L and line M are the parallel to here each other. Line L parallel to line M, and the transversal, see here, the line AB and line CD are parallel to each other. The transversal, see here, the transversal, that is, we can denote it by XY. XY is a transversal which intersects to the line AB at point P and to the line CD at point Q. Then the angle pairs of corresponding angle pairs, alternate angle pairs and interior angle pairs. The property, the theorem is related with that. I am going to remind it. Then see here, the corresponding angle pair property or corresponding angle property or theorem. Then see here, when the transversal intersects to the two different parallel lines at two distinct points, then the corresponding angles which are formed, that are congruent. That means here angle XPB congruent angle PQD. Then see here, the corresponding angles formed by transversal on two parallel lines are congruent. That is the property of corresponding angle. Then here interior angle properties or theorem. Then see here, when transversal intersects to the two parallel lines at two different points, then the interior angles which are formed here, they are supplementary. That means here angle APQ plus angle CQP is equals to 180 degree. That means they are supplementary. Interior angles are supplementary when transversal intersect to the two parallel lines. Then alternate angle property. Then see here, the alternate angle which is formed due to the transversal intersects to the two different parallel lines, then those alternate angles are congruent. Therefore here angle APQ congruent angle PQD. That are the properties which is related with the that angle pairs made by the transversal on parallel lines. That is the fundamental concepts which is related with the geometry, and that is the content from 6th and 7th day. Now we are going to discussing about few fundamental properties from Maths 1 concepts. Then on 8th to 11th day, that means from 8th July to 11th July, in those days we are going to remind the basic concepts from Maths 1. Then see here, all of you have studied the natural numbers. Natural number which is denoted by capital M, that is 1, 2, 3, 4, 5 down. Then see here, whole numbers that are 0, 1, 2, 3, 4, 5, 6, and at infinite we can write the whole numbers. Integers are nothing but these are the set of 0, all positive numbers and all negative numbers. All of you aware of that, as well as the examples of few rational numbers, that is the rational numbers which can be written in P upon Q form, and examples of those rational numbers we have already studied, that -2 upon 7, 3 upon 5, 29 upon 2 and 3 upon -5, that can be written -3 upon 5 are the few examples of rational numbers. Then see here, we will discussing about the integers. All of you have studied the set of integers. Then see here, integer is a set of 0, all positive numbers and all negative numbers. Then see here, 0 is always greater than all negative numbers. That means here 0 is always greater than negative integers. And see here, positive numbers, positive integers are greater than 0. And here the number which is right side of the 0 or are the these are increases. That means value of those number increases. And the number which are left to the 0 are all negative. That means as we move left side, the value decreases. That means here -2 is smaller than -1. That means here the numbers which is left hand side is less than the numbers which is at right hand side. That is about the integers. Therefore, we can write few examples or orderness of integers. That means we can determine which of the integer is smaller and which one is greater. Then see here few examples of it. 14 is always larger than 5 because 14 is at right hand side from the, that is then 5. Then 45 is greater than 0 because 45 is a positive integer. -29 is greater than 15 because it is a negative integer. Negative integers are, -29 is less than 15 because negative numbers are always less than positive numbers, as well as -10 is less than 0. That is about the few orderness examples of integers. You may identify the which of the integer given in the example is bigger and which one is smaller. Then we can remind few operations related with the integers. Then see here the few operations on integers. Operations on integers. Then see here first one, 30 minus 10. See here the sign of 10 is minus and the sign of 30 is plus. Therefore we can do the subtraction, that is 20. Second one, that is, see here, 45 minus 10. Then we can write this like 45 minus 10, that means plus 10, that is 55. Third one, that is 9 minus 5, that means 9 plus 5, that is 14. Then one more example, that is, see here, 24 plus 10 is, that is 34. Then one few examples which is related with those operations, that is, see here, minus 24 minus 10. Then see here, minus 24 minus 10 is the minus 34. One more example, minus 9 minus 5, that is the minus 14. Then few more examples, see here, minus 24 plus 10. See here the value of negative number, that is here one of the number is negative while other is positive. Therefore here we can do the subtraction, therefore 34, and we can give the sign of that greater number, minus 34. Like that, minus 9 plus 5, that is minus 4. These are the few operations you have already studied in previous standard. Then do the practice of those type of examples on by solving those type of examples in your notebook. Then we will remind few more concepts, that is, if the numbers are given, then you have to identify whether that number is natural number, whole number, integer, or rational number. Then I am going to giving you one chart. Then you have to complete this chart. Then see here, few numbers are given here. Few numbers are given here, and we have to find out whether those numbers are natural number, whole number, integer, or rational numbers. Rational numbers. Then see here, 4 is a natural number, it is a whole number, it is a integer, as well as it is rational number, because that 4 is written like 4 upon 1. Then -7 is not the natural number, it is not the whole number, it is integer, and as well as it is rational number. Then one more concept, that is 2 upon 3. 2 upon 3 is not the natural number, it is not the whole number, it is not the integer, but it is a rational number. Like that you can find out the number which is natural as well as whole number, integers, and rational numbers from the given exercise. Then one more, that is -7 upon 5. That is also only a rational number, but it is not the integer or natural or whole number. Then you can solve these type of examples given in the exercise of 9th July bridge course program. Now we are going to discussing about the rational numbers which can represent on number line. Then representation of rational numbers on number lines. Then see here, first of all we have to draw the number line on which there are positive numbers, negative numbers, and 0 are there. Then see here, that number line which is on which there are different points are there. If we do the marks on equal distance, then if we mark on it on equal distance, then we can represent the number on it. Then see here, O is a point on number line to which 0 is related with that origin. See here, point O is a origin, and 0 is a coordinate of that point O. Then see here, on equal distance, +1, +2 numbers are there, and here -1, -2 are. Then we have to represent the following numbers on that number line. The few rational numbers are given here. That is, for example, 1 upon 3, 2 upon 3, minus 4 upon 3 and minus 2 upon 3. Then see here how to represent those numbers on that number line. Those numbers are rational numbers. Then we can represent those numbers on that number line. Then see here first denominator. Here denominator is 3. Therefore we can make the equal parts of that each from 0 to 1 and 1 to 2, that is 3 equal parts. Because here denominator is 3, therefore we can make the 3 equal parts between 0 to 1 as well as 1 to 2. Then similarly we can do the equal parts of 3 equal parts from 0 to minus 1 as well as minus 2 to minus 1 to minus 2. Then see here, if here 2 upon 5 is given, then we have to make 5 equal parts from 0 to 1 as well as in each section. That is denominator is, if denominator is 5. Then see here we have to represent 1 upon 3. Then starting from 0, it is a positive number. We move at the right hand side from this 0 at the first point, that is the 1 part upon 3. That means out of these 3, 1 part is there. Then 2 upon 3, see here 2 upon, that is from 0, 1, 2 at the second point, that is 2 upon 3. Then from 1 to 3, that is the third part out of 3. 3 upon 3 means 1. See here 3 upon 3 means 1. Like that we can represent minus 4 upon 3. Then it is a negative number, therefore we have to move from 0 at the left hand side. Minus 4 is there, therefore here minus 1 upon 3 is there. Minus 2 upon 3 is there. That minus 1 means minus 3 upon 3. Then at fourth point, see here minus 4 upon 3 is there. Then see here minus 2 upon 3 and minus 4 upon 3, as well as 1 upon 3 and 3 upon 3. Then like that we can represent the rational numbers on number line. Then we have to remind the few more concepts about the rational numbers. Then the orderness of rational number. That means what is orderness of rational number? Then see here what is orderness of rational number? That is which one is bigger and which one is smaller number of given rational numbers. Then see here if A upon B and C upon D are the rational numbers given here, then we can write the orderness of those rational numbers. Then there are 3 possibilities. First, that is if A into D, that means we can do the cross multiplication. A into D is equals to B into C, then here A upon B is equals to C upon D. That means here if A into D is equals to B into C, then those rational numbers are equal numbers. Then see here, second one, that is if A into D is greater than B into C, then here A upon B is greater than C upon B. Then third one, that is A into D is smaller than B into C, then A upon B is smaller than C upon D. Then we will find out the few examples which can determine the orderness between those given rational numbers. If there are 3 upon 2 and 2 upon 3, those two rational numbers are given, then we have to find the orderness between those numbers. That means which is the biggest and which is the smaller number. Then see here, we have to do the cross multiplication, 3 into 3 and 2 into 2. Then see here, 3 into 3 9, 2 into 2 4. Here 9 is greater than 4, therefore 3 into 3 is greater than 2 into 2, therefore 3 upon 2 is greater than 2 upon 3. Then few more examples I am going to discussing with you here. That is if 4 upon 5 and 2 upon 3 is given here, then 2 upon 3 is a positive number and minus 4 upon 5 is a negative rational number. Therefore there is positive rational numbers are always greater than negative numbers. As well as see here, minus 7 upon 4 and minus 3 upon 5. Then we can do the multiplication. Let's see here, minus 7 into 5 and 4 into minus 3. Then see here, minus 7 into 5 minus 35, 4 into 3 minus 12. See here, 35 is greater than 12, but when we change the sign of those, then minus 35 is less than minus 12. Therefore here minus 35 is less than minus 12, and therefore here minus 3 upon 5 is greater than minus 7 upon 4. Then one more concept, the last concept I am going to discussing with you, that is the we can represent the rational number in decimal form. That means decimal form of rational numbers. Then there are few examples, that is 5 upon 2, that is the rational number which is present in m upon n form. We can write this number in decimal form, that is 2.5. Then like that 7 upon 2, it can be written like that is 3.5. As well as see here, 5 upon 4, that is 1.25. And few examples here, 7 upon 3, that is it is a 2.3333. If you do the division is like this, 7 upon 3, then 3 2s are 6, remaining 1, then we taking 0, therefore point is written here, 3 3s are 9, remaining 1, again 0 is taken, 3 3s are 9, then we can't find out, that is we get the number in decimal form 2.33330. All of you studied the value of pi is 3.14 ... That means see here, 3.142857, and that number is repeated 142857. 5, 7 and at infinity. That means see here the rational numbers which is written in decimal form. Here 2.5. Here the decimal form is terminating. That means here 2.5, 3.5, 1.25 are the decimal form of rational number. Rational number is terminating type. Terminating type. And the few numbers are there. That is 2.3333. That is also written like 3 is getting repeated many times. Therefore 3 is written once and the bar, that is dash or line, is shown on the head of that 3. That means that 3 is repeated many times. Similarly, this number, that is 3.142857. Here 142857 is repeated, therefore it is represented like this. That means those numbers are the decimal form of those numbers are non-terminating and recurring. Recurring means the few digits are repeated many times. Here 3 is repeated many times, that is recurring. And 142857 is repeated again and again. Therefore, that is non-terminating and recurring decimal form of that rational number. Then here, these are the decimal form of rational number which is terminating type. But we can write these decimal number in the form of non-terminating type. Then see here, these can be written because after 5 we can add many zeros are there. That means those are written in the form of non-terminating type. 3.5000, 3.500000. 0 can be written in the front of, at the right side of that number 5. The value cannot change. That means here it is a 2.5. Value remains as it is. Therefore, we can write those terminating type decimal form can be written into non-terminating type. That is about the rational number and the properties of rational numbers. Then you should solve the exercise given on each day from 6th July to 11th July in your bridge course program. And those exercises are also given in this video at the last slides. You may solve those examples. You should solve those examples in your notebook. Thank you.